Okay, let's look at a transformation here. Let's tweak the amplitude and the period again. So we've got 3/2 cosine of 2 theta. So the amplitude here is 3/2. That's still greater than 1. It's a fraction, but it is still bigger than 1, so we are going to get taller. Our period is 2 pi divided by that number with the variable, so 2 pi divided by 2. So this is pi. Again, think through it. When you multiply the x, it's a horizontal stretch or shrink. If it's bigger than 1, it's actually a shrink. Our period went from being linked to pi, so we're shrinking things in. So let's do the same thing. 0 is not going to change, except we are going to be at 3/2, so that's what, 1.5 instead of 1. Okay. Normally, we cross the x-axis at pi/2, so divide that by 2. That's going to put us at pi/4. Then we have a minimum at pi, so we divide that by 2, so that's going to put us at pi/2. But our minimum is not at -1. Our amplitude is 3/2, so it's -3/2, -1.5. Then we cross at 3 pi/2, divide that by 2, that's 3 pi/4. So that's that point right there. Then we hit our max at 2 pi, so divide that by 2, that's going to be a pi, and our maximum is now 1.5. So in this case, we could actually fit another cycle on the graph that we are given. So I'm going to do that. I'm just going to repeat all those points between pi and 2 pi. And fill that in. And then I'm going to do the mirror image there on the left side. Okay. Again, Desmos absolutely can graph this for you, and you can just copy it. But ideally, I really want you to understand what's going on here and how to produce these graphs, because that means that you do truly understand the trig function and what's going on with any transformations, because that's truly what these are. Yes, we're talking specifically about period and amplitude, and here in a second we're going to talk about phase shift and vertical shifts, but these really are just transformations like we've dealt with before. Okay, so you talked about sine and cosine in Math 3, but what we did not talk about was the graph of tangent. Tangent's a little bit different than sine and cosine. Their graphs look very similar. Tangent looks, I don't know, I mean, it still has similarities, but it's not nearly as similar as sine and cosine are. So let's think about values of tangent. At 0, we've got sine over cosine, so that's 0/1, so tangent of 0 is 0. Tangent of pi/4 is 1. Tangent of pi/2 is undefined. So if it's undefined, we're actually going to have a vertical asymptote right here. And vertical asymptote is caused by undefined values. So we have a vertical asymptote there. Let's go to the left, see what happens there. At negative pi/4, then tangent is going to be -1. At negative pi/2, tangent is undefined again. So we have another vertical asymptote. We could plug in a few other values there, but I'm going to now fill in this half. Now, that does not look right, obviously. Scale is very different. We talked about this the other day. Let's put it in radians. Get rid of that. Let's make our x-axis, what is it, -2 pi to 2 pi. Just so that it looks like what we're looking at. I am going to zoom out just a little bit more so you can see a little bit more of that, what the y values do. Okay, obviously Desmos does not show us those vertical asymptotes. I could put some in there. Pi over 2, x equals pi over 2, just to show myself. Let me make that a dotted line since it is an asymptote. Just to show us how that vertical asymptote fits right in there at pi over 2. But you can see what the function's doing. Okay, it gets really, really close to those vertical asymptotes on both sides, and it just keeps repeating that pattern. So let's fill that in to our graph here. We approach that vertical asymptote. We approach this vertical asymptote, and then that's going to repeat at every pi over 2. So at 3 pi over 2 and at negative 3 pi over 2, we have vertical asymptotes. And at our multiples of pi, we have x-intercepts. Tangents equal to 0 at all of your multiples of pi. And then you can fill in your positive ones and your negative ones. It's just one big pattern. And fill in your graphs. Try not to connect those with straight lines. Make them curved as much as possible. No, it's a little hard on the scale that we've got, but it is supposed to be curved there. All right, so tangent can also be multiplied by a constant in front, a times tangent of bx, but technically tangent does not have an amplitude. Okay, tangent does not have an amplitude because there's no way to measure that height. It goes on infinitely in both directions, so there's no way to measure from the middle. It does have a middle, right? That has the x-axis right now is its middle point, but it doesn't have a maximum or a minimum. So we don't talk about the amplitude when it comes to tangent. It does have a period though. Is the period 2 pi like sine and cosine? What's the length of our pattern here? If we go from negative pi over 2 to positive pi over 2, that's a length of pi. Or from pi over 2 to 3 pi over 2, that's a length of pi. Okay, so the period of tangent is just pi, where sine and cosine were 2 pi. So tangent's just kind of its own little creature there. Okay, so again, if we look at a transformation here, 2 times tangent of 1/3 pi, or 1/3 theta, that's not pi, that's theta. Even though it's being multiplied by 2, technically it still does not have an amplitude. We're going to put not applicable there because it does not have an amplitude. Now, the y values are going to get taller, but we don't talk about that in terms of amplitude. Period, it's going to be the standard, but the standard this time is pi divided by that coefficient with the variable. So pi divided by 1/3 is pi times 3 over 1. So the period here is 3 pi. So we're stretching it out. Again, remember it's the opposite. So 1/3 is actually going to make it wider there. So we're still going to go through the origin. This time we're multiplying by 3. So where we were at pi over 4, we're going to be at 3 pi over 4. And we're not going to be at 1. We multiply our y values by 2. So 3 pi over 4, between pi over 2 and pi, we're going to hit 2. Similar in the negative direction. We were at negative pi over 4, so multiply that by 3. Negative 3 pi over 4, the y value is going to be negative 2. Okay, so our vertical asymptotes, they were at pi over 2. If we multiply that by 3, that's going to be at 3 pi over 2 and negative 3 pi over 2. So it's really going to be stretched out here. So put that curve in there. You're not really going to be able to get that close to the vertical asymptote